Okay, in today's video we are going to tackle problem number 11 from Project Euler. This one is going to be actually kind of interesting. Let's find my project here. It's called Largest Product in a Grid. And it is kind of unlike all the rest of them. So let's look at what it actually is. Okay, so the problem that we are being asked to solve is to find the greatest product of four adjacent numbers in any direction. So up, down, left, right, or diagonally. So fortunately, there's only actually four conditions that we need to check. So that's up and down, left or right, and two diagonal directions. I know it shows down here up, down as being separate, left, right as separate, or diagonally as separate. And really, up and down are the same thing, left and right are the same thing, because multiplication is not order dependent. So I can multiply one way or the other and it doesn't matter. Diagonally, however, obviously this product is different than this product, so I will have to do both diagonal directions. Now, like the rest of these problems as they get harder, I don't actually know how to solve this, so I'm gonna have to think through this and I'm just gonna kind of make it up as I go. Okay, so now I have this viewed a little bit differently, but lined up again. I've had this in the /n code view, but I've got it lined up so it matches the same grid. So the first thing that I think I need to do is put all of these numbers into a two-dimensional array. I think because I'm thinking that when I actually go to do this multiplication, all of my operations are going to be array operations, and that's how I'll be able to keep this data organized. Okay, so in order to actually do this, I'm going to use a string function that is called the search and split string. So I'm going to put the string into here, and I'm going to create an offset, and I'm going to put it as 3 characters. No, I'm going to make 2 characters. And I'm going to look at what the input of that is. Create indicator. It should be 8. That is the number that, oh, no, sorry, now I need to add the actual number conversion. So decimal string to number. Do that right, yeah. So I'm going to take the substring before the match, which is the first 2 characters in the string, and I'm going to look at that number. And it should be 8. Okay, excellent. Okay, so then the next thing I'm going to do is create a copy of this, change it to an indicator. Oops, that's fine. Change it to an indicator. Going to expand this out so we can see it, and I'm going to hook it up to the match plus rest of string. And what I should see is this 8 disappear and this whole line shift over. Okay, yep, because I have taken off the first number and I put it into this number here. Then I've taken the rest of the string. Now I'm looking at that. So now what I have is like, but you can see there's still a space here, so we'll have to deal with that. But what I have now is something that can take at least the first number off of this string. I'm going to rename this rest of string, and I'm going to call this current number. So then the next thing I want to do is this same operation again, except I want to only take 1 off, create a constant, and this should be a space indicator, and then this should be the rest of the string. And I'm going to actually take this and I'm going to change this to /code so we can see it. So now what should happen is this string, this space should disappear. This should all move over 1 character, and we should see a /s here. Okay, and that is exactly what we see. What we have here is a small little piece of code that will take off a number, split it off, but then it will also take the white space. Okay, so the last thing I'm going to do is check to see if this substring is equal to either a space or a line feed. And this will give me some information as to whether I am still in the middle of one of these lines or if I'm at the end. So what I'm going to do here is put all of this in a while loop. And I'm going to say that if this line feed ever equals a new line, I am going to end this while loop. And then the other thing that I'm going to do is take this number and turn it into, I'm going to tunnel mode indexing this array, create an indicator. And I'm going to run this loop in while mode, and what I should end up with is an array of all of these numbers from the very first line. Oh, the thing I did wrong here, took me just a sec to realize. I need to replace this with a shift register so that I keep feeding the same string back in over and over. So what I was doing is just looking at the same string over and over again, always pulling off this 8, and this array was just filling up with 8s over and over and over again, probably like a million times. What I need to do is consider the string, put the new trimmed string after I've peeled off the first number and character, and put that back into the shift register so that I'm looking now at the next characters after that. So let's try this again, and what I should end up with is an array of all of these numbers. Okay, so let's check to make sure this is actually right. Okay, it is, and I should have a number, so we'll compare this real quick. 8 to 22, 97, on and on and on until we get to 8, and this should be 20 elements long, and it is. Okay, so now what I'm actually going to do is add a second while loop here. I'm going to replace this again with a shift register, and I'm going to do the same operation here, and I'm going to concatenate these again. So I'm going to index these again. So now I should have a 2D array, tunnel mode indicator, create indicator. And I'm going to end this loop, I think, when the string is empty. Oh, I think there's actually an empty string function. Whoops. Empty string path, yeah. So if this is empty, then I'm going to end the loop. And that will happen when all of these numbers, all of these lines have gone through and there's literally nothing left in the string. And I need to put this in here because I want to keep cycling through. Okay, so let's try this. We should create an array here. I'm gonna just drag this over everything and we'll see what we get. What is happening here? Oh, I know what's happening. What is happening is we actually don't need this, I think, because I think there's never a case where we're actually looking for a space. We need to also check to see if this string is empty, because on the very last iteration it takes off this number. This string here is empty. This is an empty constant, and it's checking it against this line feed, which it is not equal, and this remains true forever. I think that's what's happening, or false forever. So let's try that one more time, and we'll run this again, and there we go. Okay, so I should have an array here. Let's expand this out so we can see all of, nope. Actually, I'd probably want to make that smaller because I don't need it that big. There we go. Expand this whole thing out in both directions. And this number should match this grid here. So we can check, we'll just check a few numbers, 8, 49, 81, 52. Okay, that's good. Check over here on the right side. 48, 54, 16, 36, 67, 19. Okay, this looks like it has at least parsed this data file correctly. Okay, so now what I have is a number grid that I can actually start to think about. I'm going to delete all of this, can delete this, we don't need this stuff. And now what I have is an algorithm that can actually turn this string of characters into a number grid. This is going to allow me to actually do the mathematical multiplication operations on this grid to find out what the largest product of any 4 subsequent or adjacent numbers is. So I think how I'm actually going to do this, I'm going to need this, is I'm going to do this in parallel. I'm going to do the left and right, the vertical, the diagonal one way, and the diagonal another way, all in separate for loops. I'm going to handle them separately. Then I'm going to combine all of their products together and then check the array for the maximum. So I think what I need to do now is I need a bunch of add functions here. 2, 3, 4. Oops, I don't want those wired together. And I want this to be, so I guess actually I don't need an add for this first one. If I pull this down, it will allow me to index multiple elements at a time. So the first one I want to index 0. Then I want to index 1. So 1. And I'll explain how this is working. Then I want to do 2. And then I want to do 3. 3. And so what this should give me is individual outputs. And I'm going to create all controls and indicators. Okay, so what I should have here now, let's clean this up, are elements 1, 2, 3, and 4. This should give me 8, 2, 22, and 97. Oh, it's because I did the for loop, so it's giving me 48. It's giving me this last one here. So I'm going to do this one time. That was my mistake. Create a constant 1, and I'm only going to do this one. So let's see here. Okay, there we go. My problem was I had gone through all of this for loop every time and through the end of the entire grid, and that was throwing me off. So, okay, so now I have what I thought I would have: 8, 2, 22, and 97. And what you can see, obviously, is that I could simply just multiply all of these numbers together. In fact, we're going to do that. Multiply. How many do I need? 1, 2, 3, 4, I think. So I multiply the first two together, then I multiply the second two together. I guess I only need 3. Then I multiply those two together. Delete this. Oops. And I'm going to call this product. Clean this up to make sure I did it a smart way. Yeah, no, that's fine. And delete all these. Actually, I'm going to delete those because I might need that for debugging. And this number should now be the product of each of those 4 numbers. So let's just check that so we know we're not crazy. And we will do 8 times 2 times 22 times 97, which is 34,144. Okay, so now the next thing I'm going to do is index this into an array of these products. We need to get rid of this. There we go. And now I should have an array of these products. Okay, so now let's visible items, scroll bar. So the next thing I'm going to do is like check to make sure that this is actually correct. So we already know that the first 4 numbers is 34,144. So let's check the second set of numbers. And I think what I'm actually multiplying is the next column down. So 49 times 99 times 40. Oh, no, I'm not. Sorry. So let's check the next 2 numbers. 2 times 22 times 97 times 38. And interesting. Okay, so it took me just a sec to find out what I was doing wrong, and I discovered that by looking at this. So what I realized I was doing is I was indexing the 2D array, and then in this iteration of for loops, what I was actually doing was moving diagonally down. So if you look at this array number 2, intuitively you kind of think like, oh, it should start at 49, 49, 99, and 40, because that's the first 2 those are the first 2 numbers in this row. But what I was actually doing is this index was already 1. So the numbers I was multiplying together were not the first 4. They were 1, 2, or they were 2, 3, 4, and 5, 49, 99, 40, and 17, because I'd indexed in both directions now. So the thing that I need to do to correct this is add another for loop here. Put this inside here. Add another for loop around all of this. Do not index this, and run this, let's see, 16 times, I believe. And this will give me tunnel mode indexing. And I believe this should give me a 2D array of all of the horizontal left-right products. So let's see if that's true. No, it is not. Oh, I need to. I hooked up my wrong eye into here. I need this one. I need this one. All right, let's try that again. Okay, I think that is better. So we already know the first 4 are 34,144. So now let's do 2 times 22 times 97 times 38. 162, 184. Okay. So now the last the last ones are, let's see, 50 times 77 times 91 times 8. And that should give me a value of, let's see here, where'd my number go? 2.7 million. So I think, why did I choose 16? I think if I do 20, I should see, oh, I should have done 17, I think was my problem. Oops, yeah. Now, you may have seen earlier, I was like gonna delete all of this stuff, but you can see it helped me troubleshoot through this. I was having problems figuring out why my multiplication wasn't working, and being able to see these in real time helped me debugging. So like now that this is done, I'm gonna still leave them in there, but eventually I know now that this is working, I'll be able to delete these. So for the horizontal, or for the vertical case now, we can do something kind of cool. This is kind of cheating, but it's not cheating, it's just not very efficient. We are going to transpose this 2D array, and then we are going to do this exact same algorithm. I'm just going to copy the whole thing over again and rename this one vertical products. And because this is a 2x2 grid, a 20x20 grid, we should now get the answers, because all we did is just transpose that 2D array, so the columns are now the rows. We should be able to run this again and get the products now for the vertical cases. So let's test that. The first four are 8. Let's clear this out. So we'll do 8 times 49 times 81 times 52 should be 1,651,104. Okay, now just to be complete, we're going to check the very last one. So 36 times 16 times 54 times 48. And that number is 1.492 million. Let's go check it. Okay. 1,492,992. So kind of for free, we got this algorithm that did both the vertical and the horizontal case. Now for cleanliness sake, I'm going to delete all of these. Now that we know we have our vertical and horizontal solutions, I'm just going to delete all these, and now we have a little bit nicer, cleaner code. Okay, now the next thing that we need to do is check the diagonal cases. This one I'm not quite sure how I'm going to do, but I know I need to cycle through this array one by one. Now I think because of the way that I'm going to do this, I can't index this. So I need to disable indexing, and I'm going to have to control this manually, because you'll see here when we do an index array, this will give me, gives me now, when I plug a 2D array into here, it gives me both column and row inputs. And so I think what I need to do is something like I did before, where I take the 0th column on each of these, and then for the multiplication I need to take the 0th there, the first one here, and then the second and third for the next two. And I think what this will give me, change this, 2 and 3. And I think what this will give me are, create all controls and indicators. I think this will give me the diagonals. So let's bring this all back up here again. We're going to need to check against our original grid. I think this should give me 8, 49, 31, and 23 if I do this. Whoops. Yeah, let's save it. Whoops. Oh, I think I accidentally closed it. 11. If I do this just one time, where is my... Let's do this just once. Okay, it's going to take a while to populate. Okay, 8 to 22. Oh, I see what I did wrong here. I actually need to plug in, this is not correct. This makes sense now, obviously. When I do this diagonal, I need to take the same number for both the row and the column. That is obvious now that I write it. Okay, now here's where we got 8, 49, 31, and 23. Okay, then what I think I need to do is index. Well, let's see here. I'm going to do the same multiply operation. So let's do this. So element 1, 2, 3, and 4, and the product. Create an indicator. Product. And that should give me the multiple of both those numbers, or all those. Let's just check that just to make sure. Eight times 49 times 31 times 23. Okay, 297496, great. And then I need to index through this array in both directions. So I think, okay, so now this very last one here, 3840, should be the product of 40 times 4 times 5 times 48. 38,400. Okay, so I believe this works. We're just gonna kind of YOLO this here. And we are gonna do the same exact thing we did last time. And we're gonna transpose this 2D array. And this should give us the opposite direction. It's kind of manipulating the numbers. We could make this such that it goes back and forth one way or the other. I need the 17 over here. But I think this is going to work just fine. And I'm going to call this diagonal 2 products. Not 21, 2. Okay, not enter. There we go. Okay, so now what I should have here are 4 elements, 4 2D arrays that have these products in the vertical, the horizontal, the diagonal one way, and since we transposed it, now the diagonal the other way. So all I should have to do is array max and min. Actually, I'm going to concatenate all of these arrays. Let's see, I need to do, build array. And I'm going to build the vertical, horizontal, diagonal 1, and diagonal 2. Now this is getting a little complicated, but it's actually giving me a 3D array. I'm just going to plug all this into here to array max and min. And I'm going to get the max value indicator. This should work. Let's see. If I've done everything right, this should work. Okay, and the number is 51,267,216. And of course, we're wrong. The real answer is 70,600,674. So let me look at this and figure out what we did wrong. Okay, so it took me a little while to figure out what I was doing wrong, but let me try to walk you through it. So I had made the mistake that I could simply transpose this array for the vertical, for the diagonal in the other direction, but that was actually not right because what I was actually ending up with was a grid in both my diagonal 1 and diagonal 2 products that was exactly the same, except for that grid was transposed. Because if you think what transposing does, it takes it and basically flips it along the diagonal. Well, I was already doing multiplication along the diagonal, so as you moved left or right, like all that was doing is I was transposing the numbers that I was calculating. What I needed to actually do was get something that gave me a product in the other direction. So all I had to do was change the indices that I was going through so that they weren't all plus. So the rows I was having to subtract a column 1, 2, and 3 so that I could get it in the left direction, and then the other direction I was adding columns, and that gave me, rather than a a diagonal this direction, it gave me a diagonal this direction, because the first is 0. The first dimension, if I add 0 to it, then if I add negative, then if I look at the second dimension, adding -1, go down 1, but then I go negative this way, and then one more in this way, and then one more in this way, and so that gave me this direction, this diagonal direction. So I was able to run this again and got the correct value.